Hi. Exam 1 coming up. So, chapter 1, about 10 problems. I did tell you that the definition of the function is going to be there for 4 points. So, go ahead, mess it up, please. Function definition was given in 1.1 lecture. It's the first thing I wrote down in this course. All of the notes are uploaded, so you can go and download the PDF file off of the Canvas, right? And get that. No calculators, no phones, right? You can bring the calculators. The topics are the topics we covered in class. One important thing is to note that your 1.6 transformations problem will have 6 separate boxes for you to show the development, the evolution of the function from one stage to the next, right? So that's a good one. Other than that, everything will be identical like in class. Now, you had some questions regarding different topics, so let's just go through these. And if I'm going a little bit fast, well, you can always slow down the YouTube, right? Yeah, you can play it on a half.
You don't sound like you're drunk.
Or you can pause me. I always sound. So, even odd first. That was the first question. We did cover this in one of the sections. So functions can be even, odd, or neither. And that has to deal with the definitions for these. So to check if the function is odd, you need to be able to take f of negative x and work it out to be negative f of x. And for even functions, it has to be that f of negative x is equal to the original f of x. So if I have a function which says, let's say, f of x is equal to 3 plus x plus square root of x, we can test for even, test for odd, and if neither of those two works, then we just say it's neither. Or neither, whatever. So, I will first compute f of negative x. If you take a look carefully at the definition, both definitions have that piece to be computed. And that piece, if it equals any of these, then it's whatever. If it's equal neither of those, then the function is not even, not odd. So you compute this by replacing every x with negative x. And when we solve this, we see that this square root term is not giving up the negative. The 3 is staying this way. So not even, not odd. So this one is neither. Let's check g of x equals x to the 4th minus 6x squared plus 9. If we have this function, I will immediately check f of negative x, and that will be negative x to the 4th minus 6 negative x squared plus 9. And when you go through calculations, you know that even exponents just kill these negatives, and we land on x to the 4th minus 6x squared plus 9, which is equal to original f of x. So what we have found is that f of negative x is equal to the original f of x, which is definition for even. Yay. Yes?
Can you go over that again? I just don't understand it. It's not even and it's not odd.
Because this function that we got does not match f of x, and it doesn't match negative f of x. It doesn't match any of the definitions because they have to produce this as answers, and this did not produce that as the answer. Right? The f of x looks like this, and this is clearly not the same, so that means it's not even. And if you want to create negative f of x, negative f of x would look like negative 3 minus x minus root x. You don't have that either. So it doesn't match any of the definition ones, and because it doesn't match either one, it's not even, it's not odd, and we'd say it's neither.
So it's because the negative is inside the square root?
Yes, and we can't deal with that. So that's even an odd story. Find the domain for 4 over 5 over x minus 1. Well, what we immediately see is that x cannot be 0, right? That's given, because if you have x equals 0, then you would immediately have that this part would be undefined because you can't divide by 0. So we have to exclude 0. But also we have to exclude 5, because 5 divided by 5 is 1, and then 1 minus 1 is 0 for the main fraction to be undefined. So there are two bad points here that would make this not work. Everything else is fine. All other values, right, are fine. So we will write the domain as negative infinity to 0, and then we'll kick out 0, go all the way to 5, kick out 5, and go all the way to infinity for this problem, because this is what we have. So again, it was an analysis. Anytime you are not allowed to divide by 0 ever. And because you are not allowed to divide by 0, then you can't have x equals to 0, because 5 over 0 would be undefined and that will break everything. But you also can't have it to be a 5, because 5 divided by 5 is 1. 1 minus 1 is 0. So you can't have 4 over 0 either. Yes? It's called telepathy. Be very careful, I read minds, right? Yeah. Let go of that thought right now. All right. So that's that part, right? We got rid of this problem. The next problem is another problem that we have, which asks us to check if two functions are inverses of each other. So we have a a theorem, which says that two functions are inverses of each other if their function composition produces an x as the answer. So in 1.8, I said function composed with the inverse gives x, or function composed with a function produces an x. The other way to write the same thing is function, when you plug in an inverse inside, produces an x, or inverse function, when composed with the original function, gives us an x. The problem given to me over there says check if the two functions are inverses. I have f of x equals 6x plus 3, and g of x equals x minus 3 over 6. So all I need to do is to do function composition, which is, I believe, 1.7. All I need to do is function composition, and if the calculation spits out an x as the answer, They are inverses. If we get anything else, you get 2x, you get 5 over x, or x squared, anything else, they are not in that case. So I am going to compute f composed with g, let's say. So f is the main, that's a 6 times g plus 3. So this is the way we calculate function composition. Every x of f will be replaced by g. Every x of f is replaced by g. So g goes in here. Oops. G goes in here. So now I compute this. Again, I'm looking for x. Well, 6 will cancel 6, leaving with x minus 3 plus 3, which is equal to x. So yes, they are inverses because the function composition worked out to be an x at the end. If I say in a problem, check if the function has an inverse, you do horizontal line test. Compute the inverse. That's when you swap x and y and you solve for y, and that's your inverse. Part 3 of the same problem might be check if your solution is correct, or check if the functions are inverses or whatever. You will do function composition to check, right? So it could be a 3-step problem to check horizontal line test, to check the procedure to swap x and y to find an inverse, and then do algebra correctly. And finally, this particular problem, which was to check if the functions are. Now, one thing that I'm going to mention about function composition, which is on the list of questions that you can see in the middle, it says function composition computed at a number. I am going to remind you that y equals f of x, and this x over here is your input to compute the value. So if my f of x is equal to 3x plus 9, we can compute f at, let's say, 5 by plugging in 3 times 5 plus 9, which is 15 plus 9, which is 24. No matter what you plug in here, the heart, you will have 3 hearts plus 9 as the answer. This heart is not doing well. There we go. Perfect. So whatever goes for x, it will go for x in the calculation. Now, function composition is a way to take two functions, mush them together, and create a new function. And the new function will be just a function again, which you can plug in any number and compute values again. So if I have a function, let's say f of x, to be square root of 3 plus x minus 1 over x, and then I have g of x is equal to x squared plus 2, I don't care, right, whatever. And the question says compute f of g of 3. This means, this notation here, I'll write it in blood, means get f of g first, then compute at x equals 3. That's what it means. So I'm going to find f of g of x first, and that is, we are using f and as you can see, I am replacing every x of f with the g's. And what is a g? G is x squared plus 2. I have my function composition. The next step is to compute this. If you can't compute, supposed to compute at 3. If you can't simplify, actually we can, hold on. We can simplify now, right? Because we can write this as a square root of x squared plus 5 minus 1 over x squared plus 2. So f of g of 3 is going to be 3 squared plus 5 minus 1 over 3 squared plus 2, no coughing, and now we have square root of 9 plus 5 is a square root of 14 minus 1 over, 11? And if you really want the decimals, you can punch this in a calculator. No one cares. If you just give this as the answer, its exact value, I'll be a happy camper. So you will compute the function composition first, and then the number that is provided to you will be plugged in at the end to compute the value of the expression. Yeah.
In simplifying the equation, why didn't you take x squared out of the square root?
There's a plus 5. We can't.
Oh, okay.
Plus 5 is not allowing it. Yes.
Could you find g of 3 and then plug that into x?
Very good. You can compute g of 3 first and then plug, yes. The question on the test might be, find the function composition and so on, because that's more important than being able to compute, right? Computers would compute for us, but they can't really still put these things together on their own. So, but what you said, 100% yes. Function composition is also used in a procedure called difference quotient. So difference quotient is a formula where you take f of x plus h minus f of x divided by h. I had the whole spiel on this, also explaining that this formula is extremely important for our Calculus 1 because it gives us the derivative in Calculus 1. You absolutely must know to compute this if you are going to Calc 1. This formula is very important. It will have more features in Calc 1. Right now we just have this. And any function can be given to you as f of x to grind through the algebra of this. So pick one. Do you want square root of x? Do you want 1 over x? Do you want x squared plus 3? Do you want x squared plus 3? So f of x is given as x squared plus 3. When you look at the formula, you do have just f of x piece, which is x squared plus 3. What you don't have is f of x plus h. That's the one you have to create. So f of x plus h is going to be every x of f will be replaced by x plus h. We only have one, so x plus h squared plus 3. So what I have done is I replaced this x and this x by x plus h. And you can see it, right? Doesn't this look like x squared plus 3? It is, right? Except I removed x and put x plus h. So now we FOIL this, get x squared plus 2xh plus h squared plus 3. And now we plug all of these values in our difference quotient. We have x squared plus 2xh plus h squared plus 3 minus f of x which is x squared plus 3 in parentheses because that minus needs to distribute to each term. Everything divided by age. Difference quotient is equal to now x squared plus 2x age plus age squared plus 3 minus, kill me now, x squared minus 3 divided by age. There we go. And we cancel x squared with x squared and positive 3 and negative 3. You see that the only terms that remain all of them have age. So we factor out age, 2x plus 1 age that stays, divided by age. Now those two drop, and you get that the difference quotient is equal to 2x plus age in this case. Answer is different for every function you get. You just need to plow through algebra. The step where you are going to cancel everything and that does not have an age, and being able to factor age to cancel it will always be there. If you are not reaching a point where all of the terms that don't have age drop, you are doing something wrong. And in that case, right?
Can I ask a question?
Of course.
Could we perhaps do the difference quotient with, I would almost say something a little bit more complicated, like the square root of x, because this I understand. It's when there's like another thing in there. Like how would I then get rid of the square root, or would it just...
Well, we have to follow the algebra, right? So what is your...
Like f of x equals square root of x.
Okay. So now we're going to again do the dq for f of x equals square root of x. We also know that we need x plus age, and that is just the square root of x plus age, right? Are we all agreeing on this? Yeah? Bueno.
It's then when you throw it in
I'm going to throw it in now.
that's where I'm getting lost.
So we have a square root of x plus age minus square root of x divided by age. When we are dealing with square roots, we usually have to, knowing algebra, we have to rationalize. We are using a conjugate, which is the same roots with the opposite sign in between them. So I have to multiply this by the square root of x plus age plus square root of x over square root of x plus age plus root x. Now I am going to deal with this. When I multiply, we get x plus age minus x divided by age square root of x plus age plus root x. The x's on top will drop, as you can see, leaving us with what? Age, which can be cancelled by the age in the denominator. And when these age cancel, you are left with the answer, which is 1 over square root of x plus age plus root x. And in calculus, you're just going to have one more step. You will say age equal to 0, and your answer would be 1 over 2 root x. Okay, I have to move to chapter test because I've seen that the other class is already massing in front. So I have to jump immediately to exam. Problem number 37, problem number 30. Ooh, nice. Excellent. So, chapter test. This is page 306 in a textbook. We will start with the problem 39. That's the way they're listed. A closed rectangular box with a square base has a volume of 8,000 cubic centimeters. So I have a box with a square base. So that's x, and the height is different. It's y. Volume is given as x squared y, and that's 8,000. They say express the surface area of the box as the function of length of its side, which is x. So they want a as a function of x, actually. Okay. We will come up with a formula for surface area. I have x squared, but two of those, because I have the top and the bottom. And then I have 4xy sides. And that's my area. They want me to have area as a function of x. That means I have to remove the y. Well, I just have an equation that does that. Y is equal to 8,000 over x squared. Plug in. So a is equal to 2x squared plus 4x times 8,000 over x squared, and the a of x is 2x squared plus 32,000 over x. And that will be the answer. They're asking for the area in terms of x. Well, there it is. There are no y's. There is nothing else there.
Professor,
Yes.
can you just go back up on the screen a little bit?
Well, you'll have to catch up on the stream because we have to leave in a negative 1 minute. One more problem, 37, which has to deal with those. Remember those problems with tickets? Well, this one has the apples, as I promised, right? So if I go too quick over here, just rewind the video and go half a speed. The annual, oh no, this is the walnuts. The annual yield per walnut tree is fairly consistent at 50 pounds per tree when the number of trees per acre is 30 or fewer. So we are getting 50 pounds when the number is 30 trees per acre. For each additional tree, so plus 1 tree, we lose 1.5 pounds due to overcrowding. Figure out all of the equations. Okay. What we have are trees and pounds per trees. So we want to calculate the loss. So how's that done? We start by figuring out, first we have the subtraction, right? Because the more trees you put in, the more trees you put in, the less pounds you get per tree. So we are going to say that the trees will say the X amount of trees minus 30. So this part over here gives me just number of new trees. That's what it gives me. So, and now I am going to multiply that value by the loss per tree. So times 1.5, and all of that will be subtracted from 50 because 50 is the most I can get. So we have, so this is what, this is, now let me do this. This is going to be our loss, right? And then finally, all together is pounds per tree if number of trees is above 30. So how does this work? I mean, it should be common sense to compute these things without equation. If you are losing 1.5 pounds when you add extra tree, if I am to add 4 trees, how many pounds am I losing per tree? 6, right? 4 trees, each one causes 1.5 loss. 4 times 1.5 is 6 pounds. 50 minus 6 would be, the yield would be 44 pounds per tree. Now, you can calculate that because if you stick 34 in here, 34 trees, 34 minus 30 would be 4, times 1.5 is 6, 50 minus 6 is 44, so 44. So the yield, right, the yield would be equal to this equation, and the yield is pounds per tree. All right. If you have any other questions, I'll see you in the hallway because the next class is waiting to come in. I'm in the folder, but you also have the YouTube video